Hi, I'm Gabor and welcome to the first product demo from DataDiner. In this video I will show you how to use the RetentionKit repository. It includes a Python package that generates a wide range of retention analysis charts along with an agentic AI system that lets you chat with your data. This means that even professionals without Python knowledge can perform advanced retention analysis. Let's get started. This is the repository. You can either download it as a zip file or clone it from GitHub. This is the first version. I will continue improving it over time by adding new charts, workflows, and integrations to make retention analysis even easier. Let's take a quick look at the project structure. First, we have the cloud folder. This contains the AI skills that the agent uses. Next, we have the dataset folder. Currently, there is a zip file. We will unzip it and use it during the demo later. We have the RetentionKit. This is the Python package. This is the core of the project. It contains analysis, logic, and visualization functions, and the AI agent uses this package to generate the charts. We also have the test suite, the gitignore file, and the cloudmd file, which Cloud automatically reads whenever you start a new session. I recommend to read it. This contains the workflow and the basic assumptions we have and the repo map. Finally, we have the README and we will go through it next. Now, let's talk about the data. At the moment, the package works with CSV files. Direct warehouse integrations are already on the roadmap. The input should be an event-based dataset or fact table that records which user performed which action and when. You can have also additional segments columns like which platforms the users use, like mobile or web app, or what type of subscription they have, or what is the acquisition channel they are coming from. The minimum required columns are timestamp and the user ID, where each row should represent a single user activity. For your first analysis, I recommend include only the most important event in your product, the event that represents the moment a user experiences your product's core value. For example, for Uber, it can be a ride completed. For Duolingo, lesson completed. For chess.com, it is game played. We will use a chess example during the analysis. For Amplitude or Mixpanel, an analysis shared. For Instagram, a story shared. Using your core value even gives you the most meaningful retention metric. This is why we will use only this specific event. Once the data is loaded, the first step is to check its sparsity. Many event datasets are sparse because users only generate events on the day or weeks when they are active. This becomes a problem when calculating weekly or monthly retention because missing weeks don't necessarily mean a user has churned. They may simply have had no recorded events during that period. Package fills the missing time periods, creating a continuous user timeline. This ensures that the retention calculations are accurate before any visualizations are generated. Once that's done, we can create different retention charts. The current version generates the visualization presented in my retention article. You can read it on my blog. What type of charts we can visualize. First, we have the usage frequency histogram. This shows how frequently users engage with your product, how many days they are active in a typical month. Next, we have the retention curve, which helps you understand long-term user retention and whether your product is showing signs of product market fit. After that, we can evaluate the health of your company's growth using a lifecycle bar chart and quick ratio. Finally, we have the cohort heatmaps, which let us dig deeper into the retention trends and identify exactly which user cohorts are improving or declining over time. Now that we covered the basics, let's clone the repository and walk through a complete example so you can see how all this works in practice. This is what you have if you downloaded the repo. Now I'm using Virtual Studio Code. This is a free software, but you can use any other IDE. I already unzipped the dataset file. So let's see what we have there. We have an activity CSV, which is the data what we will use. It looks like this. We have a date column, a user ID, an event type, which is currently only game played, platform, which can be mobile or desktop, and the acquisition channel, which is organic, paid, or social, and we have an event count, which can be 1 to 4. This currently doesn't matter. We have an analysis.yaml file, which contains the most important information about the dataset. So there are like two important fields. The first one is the core action. If you have multiple events, you will need to specify the action which delivers the value of the product. The grain tells the AI how to calculate the various charts we will analyze. Now we will use a weekly grain, so charts will be calculated with a weekly frequency. And we have an exercise.md. This is the exercise we will go through. Let's read it. The data is a full year of play on an online chess platform. One row means this player played at least one rated game on this day. The log is daily, and the player has no row for a day they didn't play. Event count is how many games they played. We have two attributes, the platform and the acquisition channel. This is the data we will use, and we have the analysis config. If you use your own dataset, the AI will ask some basic questions about the dataset, and it will set up its own analysis.yaml file. How it works, we will need to run the retention analysis, and the output is written to the output folder for the corresponding lesson name. It will contain charts and various segments, and here are some exercises which we'll go through. The first part refers to the orientation, so we will need to look into the data. The second part is reading the various views. The third part is what happened in 2024. We have a few shocks which we will try to investigate, and we have some decisions what we have to make. There are some references and some information about the various charts we will use. First of all, let's start Cloud. Let's open terminal and type Cloud, and let's just ask it what is in this repo. And now Cloud will go through the entire repo, read the various files, and it will give us the structure of the repo. So this is the answer. This is a RetentionKit, a small Python package that turns daily activity log into retention figures, plus one course dataset to practice on. This is the package. We have these modules. We have the dataset. This is the lesson 1. And we have the rest, the test, the cloud skills, and the output. Nothing hard codes, just dataset. Okay, so let's start with the first question. Load the file and run the quality report. Report the rows, distinct players, date span, panel density, and the natural frequency. Then explain the panel is only 80% dense. Why is the other 82 not missing data, and what would break if you treat it as missing? So first, let's run the quality report, and we already know that because of the first part of the video that most of these event-based data models only contain active information, so the user only present in the dataset if they were active on a given day. So if we want to calculate the various retention charts week over week, then we will have a problem because the data won't tell us exactly how the user behaves, because we don't have missing values in this dataset. So that's why we need to fill it with zeros. So the report is ready. We have 3,800,000 rows, almost 130,000 users in 2024, 80% panel density, median is 7 active weeks per user, the natural frequency is weekly, density cadence matches the grain, the resurrection is real, nothing flagged on duplicates. Okay, so let's go to the second question. Generate the run, list what is in the output folder and say which subfolder unsegmented charts go to. Then the config sets core action game played, so every view is filtered to that event. Prove it changes nothing on this dataset, and name the one thing that you could have checked first to know that in advance. So how to prove it? We already know that there is only one event in this dataset, game played, so this is the reason why it wouldn't change anything. Second question, generate the run, list what is in the output folder and say which subfolder unsegmented charts go to. Then the config sets core action game played, so every view is filtered to that event. Prove it changes nothing on this dataset, and name the one thing you could have checked first to know that in advance. So let's run the overall analysis. The answer is that basically there is only one event in the dataset now. This is why it won't change anything. So let's see the results. Here we have the various charts. We have 5 heat maps, a life cycle, bar chart, and a quick ratio, and a retention curve, and the usage frequency histogram. This is what we have for the overall charts. Great. Let's go to part 2, reading the views. 2 cadence numbers disagree, and both are correct. The usage frequency histogram proves the median player at 1.7 active days per month. The natural frequency says the median return gap is 4 days. Reconcile them. What population is each one measuring? Then say which of the two should decide whether retention is computed weekly or monthly, and why. Let's look at the usage frequency histogram. The usage frequency histogram shows the average active days users have per month. X-axis is the active days, the y-axis is the number of users. And what is interesting here is that we basically have 2 types of users. Most of the users sits here with 2 to 4 active days a month, and we have another group of users who are a lot more active. So if we look back to the answer of Cloud for the relevant part, we can see that 72% of our users average less than 4 active days per month. And the second smaller hump is at 14 to 21 days a month. This is almost nearly daily players. So 1.7 isn't really describing a typical player, it's sitting between the 2 groups. And here is why. The histogram includes everybody, including the users who played once and never came back. They stay in the calculations for every month after they left. The return gap only exists if someone actually came back, so it never sees those users at all. 4 days between sessions would be about 7.5 active days a month. We measure 1.7, so for the window I would go with the return gap. 4 days means an engaged player is back more than once a week, so weekly is right. Monthly would let someone play once, disappear for 3 weeks, and still count as active. I wouldn't use 1.7 because the number is mostly produced by users we lost. Now let's go back to the exercise and let's see the 4th question. On the retention curve, find the single steepest drop and give it size in percentage point. Then find where the curve stops falling and what level it settles at. Say what the plateau tells you about the product that the steep drop does not, and what the curve would have to look like instead for you to say there is no durable core. So let's look at the retention curve. It takes every cohort and asks how much of it is still active at a given age. So x-axis is weeks since sign up, not calendar time, and the y-axis is the share of that cohort still playing. The steepest drop is no supply, week 0 to week 1. By week 5 we are at around 40%. Then it flattens out and settles about 20 to 25%, and that is our retention rate. But I don't think the first drop is really churn. These users never started. That's an activation problem, and you fix it with onboarding, not with the win-back emails. The drop is about the front door, who we acquired and how good our onboarding is. The plateau is about whether the product actually works. Because of the curve really flattens, it means a fixed share of every cohort gets to the point where they just keep playing, and that definitely indicates some product market fit. Every 1,000 signups permanently add around 200 to 250 long-term players, which is what makes it reasonable to spend more money on acquisition. And if there was no durable core, this line would just keep falling towards 0, something like this way. Some products are allowed to look like that, like dating apps or Zillow, where people finish and leave, but chess isn't one of them. If someone stops playing chess, they didn't finish, they left. So here a curve going to 0 would be a real problem. So that's our baseline, weekly window. Most users gone in the first week, around 20 to 25 of every cohort stays long term. In part 3, we go looking for what happened during 2024 that moved these numbers. Part 3, first question, How would you evaluate the growth of the company? Is it driven by marketing or by organic growth? Which figures should you look at to answer these questions? So basically, the retention curve won't help here because it has no calendar axis. It only shows how cohort decays as it ages. We need something that shows actual year, week by week. That's the lifecycle bar chart and the quick ratio, what we will use here. The lifecycle chart takes each week and splits the users into states. Above the axis, new, retained, and resurrected users. Below the axis, the at risk and the churned one. So instead of one number for weekly actives, we see what that number is made of. New means this is their first week. The retained means they have 2 consecutive weeks when they are active in a row. Resurrected means they were inactive in the previous week, but now they were active. At risk means on the previous week they were active, now they are not. And churns means that they have at least 2 consecutive inactive weeks. The one that really matters is the retained one. That's our core user base. This is the green one. What we can see is that this band isn't just getting bigger, it's getting bigger as the share of the whole bar. So the growth is coming from users who basically stay with us. We can see that in the middle of September there is a dip, and we will investigate it later, but on this figure we can see something bad happened there. If it was the other way around, the new and resurrected growing while retained stays flat, we would just be filling a leaky bucket, and that's not what we have here, luckily. Other one is the quick ratio, and is a new plus resurrected divided by the number of churned users. So how many users we gain for every one we lose. Above 1 the base grows, below 1 it shrinks. Here it sits near almost 2 during the entire year, but basically consistently above 1. So we can ignore the spike at the beginning. In the first week there is almost nobody who could churn yet, so it's artificial. Great, next question. The company ran a new marketing campaign at the end of February, March, then cut back the spending in April. How would you evaluate these shocks? First, let's look at the retention rate. A quick orientation, as this is our first heat map. Each row is a cohort. Everyone who signed up in the same week. The first column is how many signed up. Every column after that is age. Week 0, week 1, week 2, and so on. The cells are percentages, the shares of that cohort still active that age. So you read a row left to right to follow one cohort through its life, and the column top to bottom to compare different cohorts at the same age. Coloring based on columns. Because it is a rate, cohort size is stripped out and the big week and the small week can be compared fairly. Both shocks are visible even before getting into the rates. In the sign-up column, January and February sits in a steady band. Early March jumps about 20% for 4 weeks, and then April collapses. The second week of April is roughly half of a normal week, the smallest cohort on the chart. On the dashboard that counts signups, that's the whole story. Campaign good, cutback bad. Now the rates which tell you it's a wrong story. For the March cohort, we can see that the quality of the users we acquired was lower than the average. We can see that we can retain far less users than we are used to. Before March, the retention rate is above 60%, then it's near 50%, and it stays on the same level. While for the April cohort, we can see that although we have fewer users, the retention rates are quite similar to what we are used to. To get to the full picture, we need to look at the retention counts. Now it's a little bit different picture. What we can see is that for the marketing campaign, we could retain almost the same amount of users after 20 weeks than before. So based on this, the marketing campaign failed, as although we spent a lot more money on marketing, we could only keep the same amount of users than before, maybe a little bit less. For the April cutback, we can see that although we have similar users, the number of retained users stays at the lowest, near a little bit more than 500, something like that. So that's the whole story. The campaign bought volume with no durability. The extra sign-up produced essentially no extra long-term users, so cost per acquisition looked fine, while cost per surviving users is undefined. The cutback bought durability by giving up volume. Quality snapped back, but the cut went too deep and too broadly, and it took real retaining users out along with the bad ones. So the read isn't the campaign was bad and the cut fixed it. Spend was scaled up on the wrong audience and then pulled back indiscriminately. The level nobody touched is the one that mattered. Keep the budget, change who it's aimed at. Awesome. Next question. The company introduced a new onboarding flow from the end of May until July, then switched back to the old one because the CEO didn't like it. How would you evaluate it? Would it be worth keeping? So let's get back to the retention rates figure. Maybe you could previously notice that there is a really green part here at where we had this new onboarding campaign. The retention was a lot better than what we are used to. So this was a success and the CEO made a mistake. So I would go back to this onboarding flow as it retains much better than the previous one. Okay, last question in this part. 1 calendar week is bad for every cohort at once, no matter how long those players had been around. Find it, quantify the drop, and then test the claim that it fixed itself, because actives were back within a month, so there was no lasting damage. For this, let's look at the churn rate. And we can see instantly this diagonal line. This is what we are looking for. You can see the other shocks as well. So we had the bad marketing campaign and the improved onboarding here. And this shape is important because it tells us what kind of problem it is. A bad row means we acquired badly. A bad column would mean something happens at a certain age, like a 10-year milestone. But a diagonal means 1 calendar week where everyone was affected the same, whether they joined last month or last year. Let's quantify it. For this, we can look at the lifecycle bar chart and we can instantly see the drop in the retained user bucket. This means that we almost lost 5,000 users in that month, but it's coming back slowly but steadily. Now the claim, it fixed itself. Actives were back within a month, no lasting damage. For this, we can look at the retention count and look into this diagonal shock. So now I'm looking end of July, 10th week, and we can see that the number of users dropped from 900 to 600, but slowly but steadily it is coming back to 700. I wouldn't say that based on this we didn't lost any users. I'm pretty sure that we couldn't fix this properly, and this churn event had a lasting effect, but we could mildly mitigate it by time, but there is definitely some loss here. What caused it? Honestly, this dataset can tell us. We have no version, no country, no error logs, nothing like that. We can think about something like a bug or an outage. Maybe you can remember when we had a Cloudflare outage and for half a day or for a day, like 1/5 of the internet was unusable because everyone used Cloudflare and it just went down, so all the other sites went down as well. Awesome. Last part, decisions, 9th question. What would you recommend the marketing department do next? Which platform and acquisition channel should they focus on? What other information do you need to quantify the return on investment on spending, assuming there is a paid tier for the platform? For this, we need to use again RetentionKit and ask it to generate the segmented views. First, only generate the overall retention curve for the platform and the acquisition channel. Now the figures are ready. Let's look at the acquisition channel, retention curve, and what we can see is that the best retention the organic channel has, then the social channel is the next one, and then the paid one. Okay, this is something what we would expect. So usually people who find our product by themselves, they have an intention to do and just better quality users. If we look at the platform, what we can see is that the mobile platform has a lot better retention than the desktop. It plateaus near 30%, while for the desktop users we only have 20% retention. So based on this, my recommendation would be to focus on the mobile users and do a paid campaign for only them. This will just help us build better retaining user base than if we would use the desktop application. This is shown by the cloud as well. So here we have a table which quantifies the various retention rates. Everywhere the mobile is better than desktop. For the marketing channels, the organic has the best retention and the social as the second one. So maybe it would work to employ social marketing manager who works on our platforms like Duolingo and chess.com and just do the social. For the second part of the question, we would need like the marketing spendings and the subscription tiers and how much money our users spend on subscriptions. Maybe this platform has monthly and yearly subscriptions as well, so this is what we could analyze. So we will be able to calculate the lifetime value and the customer acquisition cost, and based on that we would be able to answer this question. Last but not least, 10th question. The head of product is planning the new roadmap and asks for your data-driven recommendations. The budget is tight and she doesn't know whether the company should focus on onboarding, develop a new feature, an AI analyst for analyzing games, or start a new resurrection campaign. Now we won't answer this question because we will need a new concept, some new ideas to answer this properly, and this is what the next video will be about. There is a really famous article about how growth models work on Lenny's newsletter, followed by this was the most read article, and basically we will implement this model, this specific model, when we will group the users into various user buckets, what we had with the user lifecycle bar chart, and we will calculate various new metrics like the new user retention rate and the current user retention rate, and we will build a simulation where we will quantify the various scenarios so we can answer this question properly for the head of product and choose the best alternative based on our budget. So thank you for your attention and see you next time.